Okay, so up to the last video, and it's called Applications of Confidence Intervals. So again, some of the stuff you don't need to copy down. The only way to be certain of a parameter for the population would be to take a census. And obviously this is expensive and time consuming. So basically any sample you take has to have some level of inaccuracy. It can never be 100% if you've got a sample, okay? And what you have to do is trade off the expense. Okay, so you need to decide what level of confidence is acceptable. So for instance, if you were 95% confident of winning the Melbourne Cup or 98% confident, they're pretty good confidence levels. You'd probably bet. And again, if you have an idea of the true value of the parameter, you can calculate how big the sample needs to be. So don't need to copy that down, just come across and we'll work through our way through some examples. Okay, so the probability of a Year 12 student driving to school is 6%. Question is, how large a sample would be needed to have a high confidence level within 0.5% of the true answer? So we've got high confidence and we want to be very accurate. We're going to need a fairly large sample, and so this is how it's worked out. So with a 95% confidence from previous work, the Z-score is going to be 1.96, and this answer here is 0.05. So that becomes the subject. 0.05 equals your Z-score, 1.96, times your standard deviation. So we've got P, Q over the sample size, which we're trying to work out. So we're going to rearrange the formula, so we have to get rid of 1.96, we have to get rid of the square root, and we have to get n to be the top. So first thing is we put that underneath, and then to get rid of the square, we square root, and now we've got 0.0694 over n. And with division, these two numbers can just swap positions, and now n will be out the front. 0.0694 divided by 0.05, 1.96 squared. And so you put that on your calculator, you get about 8,667, which is very large, because you wanted pretty accurate with high confidence. So you pay the price and you have to have that many in your sample. Okay, copy that and come across. Okay, so another example there, get you to read that and then pause, and when you're ready, we'll go through it together. Okay, so you're back. Now not quite as accurate. So 90% confidence is 1.645, 5% equals 0.5, and that's going to be 0.6 for your p-value. Okay, so we've got 0.5 equals 1.645 times the square root of 6, 4, and n. And so taking a shortcut, n will be 6, 4 divided by 5, 1.645 squared. So just remember that you divide by that, you square, and then you swap positions. And so when you put that on your calculator, you get about 260 people that you need to survey to get that envelope. So that's not too bad, that's doable. Copy that and come across. So this next part, you don't need to copy it down. If you have no idea what your p-value is, we need to give a value that produces the largest margin of error. And so this invariably will just be 0.5. So if you just pick 0.5, if you don't have a clue where to start, that will give you the accuracy that you need. Don't need to copy anything now, let's look at an example. Okay, so the transport car department wants to find the proportion of cars with faulty brakes to within 10% of the true value with 98% confidence. Okay, so 98% confidence, that gives you your Z-score of 2.326 from earlier work. That is your 0.1 for your answer, and we don't know what P is, so we're going to use P as 0.5. Okay, so we're trying to find how many cars. So we've got 0.1 equals 2.326 times the square root of 5 over the sample size. And again, just taking that shortcut, so we end up with 5 divided by, open brackets, 0.1 over 2.326 squared, and when you chuck that on your calculator, you get about 135. Okay, I think that's it. There's the exercises, and we are done. Thanks.